Hi everyone and welcome back. In general, when I start a class, I ask if there's any questions about the homework and we'll review those. I'll do the same during our Zoom class, but during the video lesson, I'm just going to do a quick overview just to go over some key points of the last lesson and then on to the new. In our first lesson, Lesson 1.1, we talked about real numbers, and we looked at those subsets, and there were a couple things I did want to highlight after reviewing your homework. Real numbers. The real number system has two basic components. It has the rationals and the irrational. And when I'm looking at this, under rational are some subcategories, whole numbers and integers. I could also put counting numbers in there. And we talked about how all of these can be represented on a number line by placing dots. We can use that to order from least to greatest or to compare numbers, to talk about absolute value and things of that nature. Now, as you were doing your homework, you had A, B, C, D type of thing, and I asked you to write the letter on the line of all the subsets it belonged to. Well, -4 is just an integer. It is not a whole number, but it is also a rational number. And we know that all of these are real numbers, so technically everything could go under the category or umbrella of real number. 75 hundredths, 0.75. It's not a whole number, not an integer. It is a rational number. Why is it a rational number? It can be written as a terminating decimal. 2/5. 2/5, once again, not a whole number, not an integer. It is a rational number. It is written in ratio form. It can be also written as 4/10, which is a terminating decimal. 0. 0 is a whole number. 0 is an integer. 0 is a rational number. The square root of 16. Now, some of you thought this was irrational, but the square root of 16 actually simplifies to be 4. So this is a whole number. It's an integer. And it is rational. It goes under all of those categories. Now, the square root of 3 is an irrational number. It does not have a whole number root. Okay. Remembering, and let's just add one more thing to this. If I gave you something like, let's say in number 7, we say 2/3. Okay, 2/3. If I take 2/3 and I simplify this, well, first of all, it's a ratio, so I know that it's a rational number. It's not a whole number, not an integer, but it's rational. And then when I write that as a decimal, again, if it's a repeating decimal, then we also consider that under that realm of rational numbers. So rational numbers can be either repeating or terminating. So again, when we look at this, we think about this as being repeating. So a repeating or terminating decimal goes under the category of rational numbers. Looking at those properties, this needs just a little bit of work. I really want you to copy this into your notes. It tells you what the basic forms are. It was in the previous video, and we talked about it in our last lesson. But again, I'd like you to copy this into your notes, so you can pause the video and copy them, please. Now on to our next lesson. We're going to go a little further into talking about expressions. We said that there could be verbal, which are all words, something like 2 plus 5. We can have numeric expressions. I can translate that into 2 plus 5. And then an algebraic, I would just replace one of those numbers with a variable, and that gives me my 3 basic types of expressions. So in the language of math, we've got the verbal, all words, the numeric, numbers and operations, and what our big focus is on, the algebraic, which is something containing a variable. We are going to spend some time doing some order of operations, because we know that when there is actually more than one operation in a numeric expression, in order to simplify it correctly, we have to follow certain rules, which include PEMDAS and the left to right rule. Expanding on our vocabulary, the word simplify says to perform all operations, just do the math till there's nothing left to do. And we're focusing also on evaluating. So in these first sections, we're not solving anything, we're simplifying. And if it's an algebraic expression, we're going to take out variables and put in given values and then use order of operations to simplify. So a lot of background information today. Again, I'm hoping that you stop and pause and copy these all in your notes. So order of operations and the left to right rule. You've done this before. You know the first thing you look for are grouping symbols. We generally say parentheses, but there could be brackets, parentheses, brackets, or fraction bar. If I had something like 4 plus 6 divided by 5, well, this fraction bar is telling me let's do what's on top first. It's a grouping, and then we simplify. So a fraction bar is now sort of put into that category of grouping symbols. We'll simplify powers if they appear. Then we go on to the multiply or divide, whichever comes first, left to right. And lastly, we'll do the add, subtract from left to right. So this is nothing new, but again, if you need a refresher, please stop and copy it in your notes so you can refer to it as you're trying some problems. And speaking of problems, here are the first 4. Pause and try these problems. In my first problem, even though in PEMDAS it says multiply, divide, we used the left to right rule, so the division came first. So I divide and then multiply. Now, every once in a while, you'll get the correct answer if you do it out of order, but don't count on it, okay? You need to follow the rules. In my second problem, I have an addition and a division. So division comes first. I'll bring down that 16. I'll divide, and lastly, add. Now, when we're in person or in a live session, I will be asking for you to participate. Right now, I'm going through the steps after you've made your attempt. And then, like I said, in person, I need your participation so I know if there's areas that we need to focus on or not. Here I have parentheses. So here, my first grouping symbol. I have to use my left to right rule. I'm going to have 10 minus 3, and then I'm going to square it. I keep following the rules. I'll do what's in parentheses and get 7. And then I need to square that. Final answer. 49, 7 times 7. Fourth problem, I see a division, a subtraction, and an addition. Left to right rule, there are no groupings, no exponents, and there's a divide, so that's where I begin. 24 divided by 6 is 4. Then I'm going to go left to right. I'm going to subtract, then add. Final answer, 3. Now, in problems like this, we do have to be careful, and in person or in a live session, we can share what we got as our answers, and if we disagree, we'll go back and do it step by step. Showing all your steps on these problems is important so that we can see if we do disagree where we vary. There will be times when I will purposely make errors for you to check. I call that error analysis. I'm not ready to start that yet, but that's a common type of problem that I will give, most likely even on a quiz or test. 3 problems here on evaluating. Replace these variables with given values and simplify. These are yours to do starting now. When you're done, check your work. I'm setting up the problems and I'm going to go over the answers to these and during our live session today. So until we have our live session, complete the problems on the previous slide. There'll be an assignment for you to also complete and submit. And until then, have a nice day.